Today I will talk to you about functions, how to determine what's a function and what's not a function, and how to determine domain and range of a function. So first of all, it's very important to know the definition of a function. I have it right here. A function is a relation between two variables, normally x and y. They don't have to be x and y, but those are most commonly used, where for each x there exists only one y. It's very important to remember that each and every x inside of a relation, for that relation to be a function, should only have one unique y associated with that x. First of all, I would like to show you how to determine if the relation that's given to you is actually a function or if it's not a function. Specifically, we'll be looking at relations that are given to you as sets of ordered pairs. Let's look at this first example here. In this first example, you have a list of 4 ordered pairs. In each pair, you have an x and a y, then another x and another y, x, y, x, y. So how to determine if this set of ordered pairs represents a function or if it's just some random relation that's not a function? To determine, you have to go through the simple algorithm that I have for you right here. So ask yourself, are there same x's inside of this set? Well, my x's are 2, -4, 3, and 4. So the answer is no. There are no same x's inside of this relation, meaning this relation is a function. And I have an explanation right here. If you look at the second example, we have to go through the same exact steps. So are there same x's? Well, let's check. You have a 2, a 3, a 7, and a 4. Again, the answer is no, I don't have same x's, so it's a function. Let's look at the third example. Are there same x's? Well, let's see. There is a 2, a 3, another 3, and a 4. So the answer is yes, I do have 2 x's that are the same. So are there same x's? Yes, there are. So then we ask ourselves the next question. Do these x's have the same y's? Well, let's see. The first x, that's a 3, has a 6 as its y. The second x, that's a 3, also has a 6 that its y. So the answer is yes, they have the same y's, meaning it's a function. Let's look at example 4. In example 4, you have 4 ordered pairs. So we start from the beginning. Are there same x's? Well, let's check our x's. You have a 2, a 3, a 2, and a 4. So the answer is yes, I have 2 of the x's that are the same. I have a 2 right here and a 2 right here. So the answer is yes. Do these x's have the same y's? Well, let's check. The first 2 has a y that's a 4. The second 2 here has a y that's a 6. So the answer is no, they do not have the same y's, meaning it's not a function. Let's look at the fifth example. This does not look like a set of ordered pairs, however, it can actually be written as a set of ordered pairs. All of these are x's, all of these are y's. So what you do is you use the arrow to determine which x is associated with which y. So for example, this 3, which is your x, is associated with this 1, which is your y. So it's 3, 1, that would be a first ordered pair. This is 4, 5, then a 5, 2, a 6, 4, and a 7, 1. If you write this as a set of ordered pairs, which I did right here, then you're able to go through the same exact algorithm as we did before. Are there same x's? Well, let's check. 3, 4, 5, 6, and 7 are your x's. The answer is no. Going back to our algorithm. Are there same x's? No, it's a function. In this example 6, you can represent this picture as a set of ordered pairs. So for example, here you will have 3, 5, and then 4, 1, and so on. And I wrote them for you right here. This is the set of ordered pairs. So the question is this a function? Going back to our algorithm, the first question we ask ourselves is, do we have the same x's? Let's check. 3, 4, 5, 5, 6, and 7. So the answer is yes, we have two of the x's that are the same. So if you compare it with your algorithm here, are there the same x's? Yes, we have the same x's. So the next question is, do these x's have the same y's? Well, let's check for that. Do these two 5s that are x's have the same y's? The answer is no. One has a 4 as its y and one has a 2 as its y. So if the answer is no, it's not a function. Sometimes functions are given to you as graphs. I have 3 examples here. Notice that our x-axis are horizontal axis that are drawn in black. Our y-axis are vertical axis that are drawn in black. And our graphs are these bold curves that are drawn in blue. If a vertical line passes through the graph, meaning through the bold blue curve, at more than one point, the graph is not a function. So there is a vertical line drawn here, the orange dashed vertical line. The question is, how many points does it have with the blue graph? How many points does it have in common with our blue graph? The answer is 1. If there is only 1 point, it's a function. If you check this picture, you have a vertical line and a graph. How many points of intersection does this vertical line have with your graph? The answer is 2, here and here. If a vertical line passes through the graph at more than 1 point, the graph is not a function. That's why this isn't a function. And this isn't a function for the exact same reason. So sometimes the functions are given to you as equations. And I have 3 examples of equations right here. All of these equations can be written in what's called function notation. In a function notation, each y is replaced with either f of x, a g of x, an h of x, or any other letter of x. Can be q of x, p of x, d of x, any letter that you like to use. F, however, is used most often because a function starts with f. This is read function of x, or f of x, equals 4x minus 3. This here is read g of x, or function of x, equals 2x squared minus 3. And this here is function of x, or h of x, equals negative square root of x plus 1 minus 4. If you don't feel comfortable with these notations, you can always replace them with y's and write your equations like so, and that's exactly the same thing. When a function is given to you in function notation, you may be asked to evaluate that function. So the question will provide a function in function notation, and it will say find f of 2 for that same function. What it's asking you to do is to simply replace x with 2 inside of that equation. So notice right here, f of 2, which is what the question is asking me to find, is equal to 4 times 2 minus 3. 4 times 2 minus 3. I'm replacing x with 2 inside of my equation. And when I calculate it, I get that f of 2 is 5. I'm done. Sometimes I see students trying to get f by itself. F of 2 is one solid piece representing the value of y when x is equal to 2. So please do not try to get f by itself. When you find that f of 2 is equal to 5, that is your final answer. And then I'm finding g of negative 1 if g of x is 2x squared minus 3 by simply replacing x with negative 1. And then I do the same with function h here. You can go through those examples on your own. Sometimes functions are fractions. These functions are also called rational functions. Remember that if you have a fraction, you are not allowed to have a 0 in the denominator of any fraction. Because remember, if the denominator of a fraction is a 0, the fraction is undefined. So sometimes you may be given a function that is a fraction, and you are asked what value of u should be excluded from the domain of this function. What it's asking you is simply what value of u would turn this denominator into a 0. What minus 2 is a 0? Well, 2 minus 2 is a 0, which means u should never be a 2, or the value of 2 should be excluded from the domain of this function. Finally, what is the domain and what is the range of any function? Well, domain is all the x values that are suitable for that specific function, and the range is all the y values of that function. If a function is given to you as a set of ordered pairs, it's very simple to determine the domain and the range. What you do for the domain is you simply list all of the x values of that function. So notice that for this set of ordered pairs, I have x values of 2, 3, and -1, and that's what I listed for the domain here. And then the y values are 6, 7, and another 6, and that's what I have listed here. Despite the fact that 6 repeats itself twice in 2 of the ordered pairs, you don't need to list it twice in the range. Also notice that I have the braces around the domain and around the range. This is common when you're trying to list several things of the same kind in mathematics. Here I list 3 different x's, here I list 2 different y's. Originally, there were 3 different ordered pairs listed. If we're working with the list, we normally put figure braces around that list. So let's look at this function here, and we're going to try to find its domain. Remember, domain are all the axes of the function, and we are going to describe all those axes in interval notation, meaning we're just going to state where those axes begin and where those axes end. To determine where the axes begin, you need to place yourself into the furthest left point on the graph. So make sure that when you do that, you find the point so that there is no more graph to the left of it. It looks like this point is right here. Because if you go further to the left, there is no more graph beyond this point on the left. So ask yourself, what is the x value of this point? Well, the x value of this point is -2. That's where your axes begin, at -2. Then we need to find the point that is the furthest to the right. So when you do that, make sure that there is no more graph beyond that point to the right. This is this point right here. What is the x value of this point? The x value of this point is 3. And that's where your axes end. The only thing that's left to do is to give these numbers either brackets or parentheses depending on whether the circles that these points have are open or closed. Both of those circles are open, so both of these numbers will get parentheses. So similarly, we're going to find the range. To find the range of this function, you're going to think in terms of y. Remember, range is the y. And you're going to place yourself in the point that is the lowest on the graph to make sure that there is no more y's, there's no more points below that point. That's this point right here. So ask yourself, what is the y value of this lowest point of the graph? The y value is -5. That's where your y's begin. So now let's find the highest point of the graph. Well, the highest point of the graph is this point right here. What is the y value of this point? The y value of this point is 4. Let's give these numbers brackets or parentheses. -5, which is right here, this point. has an open circle, so -5 will get a parenthesis. 4 on the graph, this point here that has the y value of 4, has no circle. It doesn't appear to be closed or open. Well, because there is no open circle and the graph actually passes through this point, we are going to give it a bracket. So now let's do the same with this graph here. Let's first start by determining the domain of this function. So we're going to place ourselves into the furthest point on the left of the graph, and that's this point right here. What is the x value of this point? It's -5. -5. The furthest point to the right of the graph is this 2 right here. However, if you kind of continuously go through this graph, you notice that you have a break between this point and this point. There is no coverage between these 2 points on x-axis. So here's what I'm going to say. My x's do begin at -5. Then they stop at this point with the x value of -4. Then the x's pick up again at this point, which has the x value of -1. So -1, and then you keep going until you hit this point with x value of 2. Now let's give these numbers brackets and parentheses. So the point with x value of -5, it's this point here, has a filled circle, so -5 will get a bracket. The -4 has an open circle, so it will get a parenthesis. This -1 has an open circle, so it will get a parenthesis. The 2 has an open circle, it will also have a parenthesis. Because your domain here consists of 2 separate intervals, you need to make sure you connect them with the union symbol. This is the domain. So now let's determine the range of this function. To determine the range, you need to first determine where the lowest point on the graph is. And that's this point right here. There is no more graph below this point. The y value of this point is -2. The highest point of the graph is here. And while it looks like a range should consist of 2 chunks, this one and this one, similarly to domain, it actually will only consist of 1. It will start at -2 and it will stop at 3. Well, some of you may say, why won't you have this chunk here of y values between 0, remember this point has the y value of 0, and 1. This point has the y value of 1. Well, think about it. If you say that your range begins at -2 and stops at 3, like that, won't the values between 0 and 1 already be covered by the values between -2 and 3? They will. Because if you say you begin at -2 and stop at 3, the values between 0 and 1 are already included into this interval, so you don't need to repeat them. Now let's give these numbers brackets or parentheses. -2, which is this point with the y value of -2, has an open circle, so we're going to give it a parenthesis. 3 here has a closed circle, so we're going to give it a bracket, and that's your range.